Hi, my name's Layne Vincent. I started programming in 1987 with a language that has now become somewhat obscure called SGML, the Standard Generalized Markup Language. What makes SGML special is that it is the precursor and the father of a language we all know and love, which is HTML, which, as we all know, is also the precursor and the father of CFML. So that's our tie back to ColdFusion. In about 1998, I was working for Northern Telecom, and my boss walked into my office and said, "Hey, do you know how to get information from our database?" Which was Access at the time, from our database over to our web page. And I said, "Well, I can find out." So I did a little research, and I actually started programming in CF with version one, Alere CF version one. So I go way back with those guys. I continued being a CF developer up until 2014. I always had a love for the database side of it, much more so than the CF code side. Um, and in 2014, the company that I was working for, that I was hired into, we had a team of three developers. We had a greenfield project, and one of the three of us took the front end, one of the three of us took the middleware, and one of the three of us took the database. I took the database, and that began my career 10 years ago or so, actually almost 11 years ago now, as a full-time DBA. Since then, I've taken multiple classes and learned the tricks and the ways of my trade. But I've been a full-time DBA now for well over 10 years, and love every minute of it. There's an evolutionary process that happens with small companies, and it affects many different facets of the company. But as a small company grows, those who wear multiple hats wear fewer and fewer hats because they hire people to take over some of those roles. Um, so, for instance, what you'll see in a very small company of maybe 5 to 10 people is you'll generally have a single developer who wears all the hats. Well, at some point, he might get lucky, and the boss might say, "Well, okay, we need to bring in somebody else to help you." The real issue on the database side of it is most developers know enough to be dangerous with databases. I don't mean that negatively. I mean that they're quite competent, but they're quite competent at writing queries. They're quite competent at writing stored procedures, but they're not necessarily competent in maintaining a highly active data system. They're not necessarily DBAs. They sometimes call themselves that, and that's okay. But they're not really the guys who know how to go in and tune and not only tune the queries, but tune the server. Um, so a big challenge for companies that are graduating, they're growing, they're vibrant, they're adding people, the big challenge is deciding, ooh, we need to start talking about having a real DBA in here. Initially, they probably don't need him full time. I have several clients where I'm not full time with them. They use me on an ad hoc as needed basis. Most of them, yeah, I would, if I had to guesstimate, I would say roughly 10 hours a month is what a lot of them have me do. They call me, they say, "Hey, we got this query. Can you help us with it?" Sure. "Hey, our systems aren't running properly. Can you help us with it?" Sure. Um, the point at which a company decides they need a full-time DBA is a big step because that's a big salary that you're having to add to your company. Or if you're using consultants like us, that's another cost that's added to the cost of your whatever projects you're working on. My hope with this database or DBA as a service is that we can provide for these small to medium sized companies specifically a bridge from them knowing they need DBA services to them pulling the trigger on hiring a full-time or part-time DBA. There needs to be a bridge in there somewhere. Um, Other challenges that we see frequently with smaller companies, especially, um, I'll use as an example another company that I'm working for. The company was founded in 2005, and many of their databases, their schemas, their table structures, all the things that make up their data systems date back to many years ago. Maybe not 2005, but they go back to 2015 or to 2010, or maybe even earlier than that. They've had multiple people working on them over the years. They've had many, many different fingers in the pie, as they say. And so what you have is let me see how to word this correctly. You end up with a database that is inconsistent. Inconsistent with things like naming convention, inconsistent with schema, inconsistent with even things, base level things like backup strategies. That when you have multiple people working on the same thing over years, there are so many different ways to do so many different things, and everybody's going to choose their own path. So one of the big challenges that we see with these small companies is they know they have good data. They just can't really get at it because it's very difficult to get at it. You know, one guy 5 years ago decided that denormalizing this table was a good idea. Well, now they're stuck with a denormalized table, and they need to get that fixed. So that's challenge number two is understanding it's technical debt. I realize that that term gets thrown around a lot, but that's what this is. We're talking about technical debt for these people. That's challenge number two. It's it's funny, and I don't know how valuable this will be, but it's funny how one tends to put on the back burner those things that aren't broken, and it's rare that your database is actually broken to the point where it no longer functions. That's rare. That doesn't normally happen. But what does happen over even a relatively short period of time is significant degradation of your data systems in general, but specifically your ability to retrieve data and or to write data. Well, you've heard the term, if it ain't broke, don't fix it. I think that's a fairly common term. With databases, I feel like it's more of a, if it ain't broke, ignore it. So that's what people do. Ooh, that's easy. So imagine you're a small company. Imagine that you have a really competent, and I mean, a really sharp guy working for you, or a girl, or a team, or you've got some really sharp people working for you. But they're developers. They started life as developers. They started with your company as developers. Yeah, we can do the whole thing. We're full stack people. Well, you're going to reach a point where that person is going to reach the Peter principle, which, are we familiar with the Peter principle? It's where everybody will accede to their own level of incompetence. Everybody will reach it at some point. And so you have these really smart people who find themselves not knowing the answers to certain questions. And that's when you as an owner of a company need to start considering using someone like a DBA as a service. Reason being, initially, so that your really smart people can ask really smart questions and get, hopefully, really smart answers. It doesn't need to be an engagement where the DBA comes in and actually does everything for you. I have a client right now where that's exactly what we're doing. We're in more of an advise and consent role than an actual production role. But you reach a point where you need to be able to ask these questions, and you need somebody on demand. You need to say, hey, I got an error message last night that said our backups failed. Why are our backups failing? Come figure that out. Okay, that's easy. So that's why DBA as a service is and will be valuable to small to medium-sized companies. They don't have the expertise. They don't want, and then notice the way I'm wording this, they don't want to afford the expertise. Not necessarily they can't, they just don't want to yet. It's not time yet. But they do need somebody they can call. Lift and shift in essence is very simple. We're going to take your existing database, we're going to migrate it to the cloud, we're going to get it all set up, and then we're going to change your data sources to look at the new database. There are inherent obstacles that come with that. For instance, concurrency. We have to make sure that at the point we switch over the databases, they are both identical. So that's a bit of an issue. Might lead to some downtime there. But lift and shift can be a good strategy if you've determined that it is economically feasible to move to the cloud. I worded that very carefully on purpose because I have found in many instances it is not economically feasible to move to the cloud because you have a company will have existing assets that are bought and paid for. And moving to the cloud incurs a new monthly cost that they didn't have previously. The idea of lift and shift is easy to wrap your arms around. The realities of lift and shift are not as simple. If the client has determined that they want to do this, then doing it is not hard. Well, let's be fair. Doing it is not hard depending upon the complexity of their existing ecosystem. If they have a wildly complex ecosystem, yes, it's going to be more difficult. But if they're a small business that has a few databases, then no, it's not difficult to lift and shift. Performance and scalability are two different things, obviously. How are we going to help with performance? Any one of a number of ways, from simple tuning of queries and views and procedures and functions and things that access data, objects that go in and grab data, or conversely, objects that write data. There's I don't like to speak in absolutes, but I will. There's always room for improvement with any types of objects that are data acquisition objects in a database. There's always room for improvement. With regards to scalability, where we can help them with scalability specifically is if we understand their load and their current load, their anticipated load, their historic load, we can begin to develop trends and see trends. And in doing that, we can help them understand what they need and where they need to go. For instance, a company that is located in their data systems are located in-house, and they have however many servers, and those servers have however much disk and however much RAM. And they show us what their current load is. They show us what their we're able to look at what their previous load was, and they tell us, oh my gosh, we just landed this huge client. It's going to triple our business. Well, first off, great problem to have. But second off, we can then help them to decide whether or not it's going to be advantageous to them to A, lift and shift, or B, expand their current footprint. With regards to scalability within Microsoft SQL Server itself, scalability within Microsoft SQL Server is almost a no-brainer, and I don't mean to oversimplify that, but it's really quite true. SQL Server will grow as much as you grow. Where the scalability issues start really coming in when it is where you're dealing with numbers of concurrent users. How many servers do we have in a cluster? Do we need a cluster at all? How many little things like, okay, so our database has grown to pick a number of 500 gigabytes, but we have only a single file for that, a single MDF file. How and in what ways do we need to break that file up so that we have better data access for people? Because you can get really granular with the files in your database, up to and including things like you've got this one table that's getting beaten up every single day, but you can put that table in a file by itself and just let it roll, and SQL Server will be quite happy about that. Rest of the files are not getting accessed all the time. That one file is getting beaten up pretty badly. Okay, the rest of the database isn't suffering for it. So scalability is a broad range of things, broad range of topics, and really it's difficult to envision what's the word I'm looking for? It's difficult to envision how to tell someone what their upgrade path might be without knowing what their current systems are. So again, not trying to be vague, just there's no way to determine the answer to that question without looking at a specific environment. I work with a client of ours, long time customer. longtime client. And um, when I was first brought in to look at their systems, I noticed several things that were performance hindrances and scalability hindrances and so on. Um, we proceeded to look at um, how they were managing their server instances. So we pretty quickly recommended that they go with, now this is an older installation, so this terminology is not really applicable to anything past SQL Server 2016, I think. But we recommended that they go with mirroring so that they then have redundancy. They already had a few other methodologies to replicate their data. We simplified those replication processes to reduce the repeated load of the jobs doing replication throughout the day. We stood up several other servers for them that were used for things that they hadn't previously thought of. For instance, we stood up a server for them that handled only their reporting. That's all it does. It's a report server. That way, report users are no longer hitting the primary server that the customers are hitting. Report server is only seen by in-house people. The main production server obviously is seen by the world. That reduced a lot of load. We went through and granted this was an older database, right, or an older cluster. Um, and so we went in and we found certain inconsistencies that were a result of what I spoke of earlier, which was these systems were designed initially back in around the year 2000. And so we got 25 years of development going on them. There were multiple areas inside this system that could be cleaned out. When on their main database was, when I first started working with them, was about 700 gigabytes. I almost immediately had it down well below that just because of redundancies that were going on in there. There were just simply redundancies that didn't need to be there. So yeah, if we're able to wrap our arms around an environment, it's not difficult to see where tuning and growing and or pruning even can be highly advantageous. That that is a question that on the surface of it is quite easy. On the surface of it, there are long established best practices for data security, regardless of platform, regardless if it's SQL Server, Oracle, or whomever. There are best practices that have been in place for years and years and years and years regarding security. Well, that's the easy part. The hard part is getting the client to buy into them. And what I mean by that is, again, I have another current client right now, and I was running a check the other day to see what their security systems look like. And they had 25 or 30 different people who have DB owner permissions on all their databases. DB owner? Why would you set somebody up as a DB owner other than a DBA or the owner of the company? And when I questioned them about this, their answer was, "Oh, well, they need access, but they don't need that access. You need to be able to read." I said, what I did was I put together a little questionnaire, and I said, for each of these people, describe to me what access, what they need to do. Do they need to read? Do they need to write? Do they need to change the schema? Because a DB owner can change the schema. So I said, just clue me into what these people need to do. And when it came back, almost all of them, with the exception of myself and the owner of the company, really just needed read-write access. They didn't need to be able to create new tables. They didn't need to be able to create objects of any type, just read-write access. But again, we're back to that. A lot of developers know enough to be dangerous and and I don't want to say pretend, that's pejorative. A lot of developers know enough to be dangerous, but they're not DBAs. And so with a developer, the first thing a developer thinks, because I did and I do, is access. I want all access. Give me everything. And if left to their own devices, that's exactly what they'll do. And so in this particular case, that's exactly what they did. No harm, no foul. It's just a different mindset. But we straightened it out, and we got everybody. Some of them complained, but in the end, they really didn't have anything to complain about. So we got everybody straightened out and got all that DB owner access taken away. Is that's part of the challenge with security. The other challenge with security is in SQL Server and others. There's the concept of both local and domain accounts. So a local SQL Server account, for instance, mine is generally L Vincent. It's only good on a single server. You can have it on multiple servers, but they will not line up because their IDs are different. And you can grant that account whatever permissions you want. The other side of that coin is you have domain accounts, Windows domain accounts, just like we all use to log into our networks. And you can assign people to groups, and then you assign that group to permissions in the database. Well, then it's kind of out of the hands of the DBA at that point, because we're not domain administrators and we have no control over who they add to the administrators group. So again, best practices say give as few people as possible maximum access to your data systems. And yet it's difficult to get companies to buy into that because they see it as oftentimes they see it as, well, it just makes it easier if they have access. Yeah, I agree. Also makes it less secure. Another area that we see fairly frequently in older CF applications, older applications in general, but it's a best practice for databases, period. And that is the older CF code oftentimes does not use what are called parameterized queries. And that is, so you have your query written in ColdFusion with a CF query tag or similar CF script tag. And you say where X equals 1 in the where clause. Well, what you should be doing there is saying where X equals, and then use to put it in the tagged language. 10 years ago when I got out of ColdFusion, they were still using tags all the time, not necessarily CF script that much. But anyway, you have a CF query param tag. And what that does, that parameterizes that particular value that is being used in the where clause such that it can't be altered in the URL. Because if you just pass the value in the URL, well, anybody who knows how to manipulate URLs can change that value. So you risk SQL injection at that point. So we see a lot of that in the code. I can think of 2 or 3 clients right now where if I was to get into their code right now, I'd go find several instances where they could have SQL injections going on. So again, best practices say don't do this. Getting buy-in from the client to go back and alter a bunch of their old code if necessary, oftentimes more difficult. Security is subjective. I mean, there is an objective way to look at it, but then companies begin to decide, yeah, but we don't need that, when in fact they did. So. For a small to medium-sized company, if you recall earlier in this interview, I discussed how a company reaches a point where they need a DBA, but they just either don't want to or can't afford it yet. When you migrate to the cloud, I'll use Azure as an example. There are several different tiers, and the highest tier, or high, I don't know if highest is actually appropriate. One tier is where you are doing nothing more than renting a server from them. You are responsible for anything installed on that server up to and including SQL Server. They'll sell you the license, but you're responsible for anything and everything. So it is effectively just like a computer you have on-prem. Okay, all you did was move that server to a new location. You're still totally responsible for everything except Windows updates. But all SQL Server updates, everything, every piece of software you install, you're completely responsible for. The middle tier is sort of a hybrid, and that is where you have a server or a cluster of servers that you're renting. They come in and install SQL Server and they keep it up to date, but you are responsible for everything else that goes on, with that SQL Server. So it is, they say, if you go out and look at Microsoft, they will say it is almost like having your own instance on-prem. Almost. But they say, but we take care of a lot of the mundane tasks for you, which is true. And then there's the last tier where really all you have the ability to do is add users, create tables and objects, and that's it. They maintain every other aspect of your server. For a DBA, option number one, where you're responsible for everything, well, I admit it, that's my favorite one, because I want to be in control of everything. Uh, don't mean to sound like a control freak, because option number one is best for DBAs because that gives the DBA complete control over what's going on with his server or servers. Option number two is excellent for small to medium sized companies because they don't so much need a DBA. No, let's not say that. Excellent for small to medium sized companies because while they still need a DBA, the load for that DBA is going to be greatly diminished. The DBA will really be responsible for doing the frankly most fun tasks a DBA has, which is tuning queries and making sure stored procedures are doing what they need to do, and making sure that all the internal workings are working like they're supposed to, and not having to worry about patches and updates and, oh my gosh, what's going on here? Are they going to deprecate this? No, just let somebody else handle that. The DBA gets to do the fun DBA stuff in the middle tier. The bottom tier, you really only need a DBA for tuning at that point. Everything else is handled. Not my favorite tier. Based on my experience, at that point, when you start talking about scalability, where Ortus can be very handy is when we specify and help direct them to the solution they need. Kind of wordy. If we're able to help them design the system, then scalability like that for seasonal users is not going to be a problem because all you have to do is tell AWS or Azure or any of them. I'm assuming Oracle's new cloud system. Just tell them, hey, as load increases, spin up new servers. Spin up new servers, make everything work, rock and roll, go do your thing. I do have personal experience with this. Company I worked for called Platform Q, excellent folks, by the way. We moved to the cloud. We moved to AWS. And we were one of those companies that would go along with 200 to 300 users a day until we had our big show every year, at which point we'd have 60,000 concurrent users. So we go from 200 to 300 to 60,000, like almost immediately. And we sat and watched. It was amazing. We sat and watched as AWS, at the first time we had a big show, we went from a single set of servers, and I don't remember the exact configuration of those. We went from a single set of servers and we watched it spin up 28 additional instances to cover the load. Oh, and when the load subsided that evening, it spun them all down. That's how you handle concurrent users. That's how you let AWS or Azure handle it. You just make sure that whoever helped you design the system helped you design it properly to be able to do that. Nice. My advice to companies would be to allow yourself the opportunity to be open-minded enough to realize that technologies change, they get better, they rarely get worse, and it is possible that what worked yesterday, it's not that it won't work tomorrow or the next day, it's that it might work better tomorrow or the next day, and that's where a company like Ortus comes in handy. It's our business to make sure that we know these things. It's our business to make sure that we're up on current trends. Heck, it's our business apparently these days to set those trends, which I love. So yeah, that would be my piece of advice is give yourself the opportunity to understand that we might be able to do this better and that what's always worked might not be the best solution anymore. They can expect expert recommendations and observations. Benefits would include enhanced security protocols, enhanced security best practices. Speed, maintaining the servers, tuning, speed is what it all comes down to. DR, which is disaster recovery, helping it. We can certainly help implement plans to maintain disaster recovery to pretty much whatever interval you want. There's an old axiom in disaster recovery that the closer to real time that you get, the more expensive it becomes. And that's absolutely true. However, SQL Server has real-time DR kind of baked in with high availability clusters, or what used to be called mirroring. Um, that makes life a lot easier for us guys who are worrying about disaster recovery, because if the server goes down, you just flip over to the other one. We can also be very beneficial in future proofing and recommendations for growth.